Hello and welcome. My name is Marcin, and today we'll be looking at Minecraft. And to be specific, we'll be looking at how to unit test a mod for Minecraft written in Kotlin, which, as it turns out, it's not as obvious and easy as it might seem, but with the correct set of tools, we'll be able to accomplish this. The trick is that this time we will have to build the tools ourselves. Are you ready? Let's go! Here I have created a sample mod from the tutorial on the Fabric website. The link will be included in the video description. And what I did is basically a new item that's called teleporter, and what this item does is upon use it just teleports me 4 blocks away on the x-axis. And this is the basic code. We can run this to check if the item works. And here I am. I can give myself the item. And just to make sure that I'm facing the right direction, I'm currently facing towards -x, so let's check if this item works. And yes, this item correctly moves me 4 blocks, but this item has one specific bug. If the target block is a solid block, I get teleported into the block, and this is something that we do not want to have. So let's fix this, and by the way, let's create a unit test for this, so that we can make sure that it will never happen again. The sample modification project comes with no support for unit testing, so we need to add some dependencies to this. So let's start with junit, assert j, and with this, let's now add the task for the test. And now let's start writing our tests. We need to create the relevant directories. And here we have our class. So for starters, let's create something that we will call a smoke test, just to check if we can instantiate our item in the unit tests. So here I will use the Kotlin backtick notation, which lets me use white spaces and other characters in function names. And what we will do here, we'll just create the item. And we will check that our item is not null. So let's run our test. And our test failed because it cannot initialize a class. And the reason here is the toggleable feature class, which in the class initializer has a set of something called registry keys, and this tries to get some Minecraft related registries set up and the keys for them. And the problem is that this toggleable feature, as we can see, our item implements the toggleable feature, so anytime we would like to instantiate our item class or use it in our test directly, then we will run into such errors. What I try to do with this, I try to manually bootstrap the registries, but it also failed, and basically I do not want to read the whole Minecraft files, the whole Minecraft data into the memory for our unit tests. So I decided to try something else and make an abstraction of the item that will not use any Minecraft specific classes. So let's do this right now. We will create an interface for the player, because the player entity also can give us some problems. So let's just strip our player entity of all the Minecraft related things that we don't want to initialize. So now let's create an extension method that will wrap our player entity in this new adapter that we have created. And with this, let's create another class that will define the behavior of our function, in which we will use our adapter instead of the Minecraft specific class. And here we will return an action result, which we will later wrap in the typed action result. And now, once we have wrapped our player entity in our adapter and we have extracted the behavior of our item, let's move to our test. And now, since we don't depend on the Minecraft classes anymore, we can just create a normal test. And also here we have to create a class for our player. And here we create our user and put it in these coordinates. And now we can test our behavior. And we expect our user to be moved 4 blocks backwards on the x-axis. Okay, so now that we know that we have our test and the test succeeds, we can start working on our fix. And for this, we will need information from the world and information on the block state. So again, the first thing we will do, we will create adapters for our classes, so we won't depend on any Minecraft related logic. We'll start with the block state, which is the block in the world, and then we will move to the world. Basically, all we care about now is whether the block is an air block or not. Now let's change our function. Now instead of the user, we will also use the world. And let's create a function that finds our destination. And now that we have our new behavior class, let's check in our tests if our logic is good. Let's start with creating our implementation of the world adapter. And our world will just hold a list of non-air blocks, and it will return air for everything else. And a default and one more method to add blocks to our world. And now let's use our world in our test. Since we're starting at the position x10, so let's create two solid blocks. And here we expect to move to not x6 but x8. And we have a small bug in our logic. Now all our test passes. As we saw, we had two small bugs in our code, so it's good that we have unit tests. And now let's see if our logic works. So here we are again. And we are not getting teleported into the tree anymore. As you can see, everything works just fine. You may think that what we did today is we wrote a lot of code only to test a small subset of functionality, but in truth, the real value is that we have started to create a library, a framework that will, in the future, help us writing unit tests for our Minecraft mods. Right now, our framework has very limited functionality, but in time, as it grows, and as we will add new adapters, as we will adapt other Minecraft classes to use in our unit tests, it will provide much more functionality and it will be much easier to unit test our mods. And this is what I will do in the future. In the next parts, I will expand our framework, our library, with new functionalities and use it to test other parts of Minecraft mods. So, if you're interested in this, or if you're curious where it will take us, like I'm very curious, then join me next time. And until then, thank you for watching, and have a good day and happy coding. Thank you and bye.